Okay, this is for Algebra 2, and this lesson is about common logs. The first thing we want to remember is when we're talking about base 10 logarithms, if they do not put the base, it is a base 10. So, for example, if they just said log of 4, that means log base 10 of 4. When you're finding common logs, it's very simple. You simply use your calculator. For log 3, you would press log, which is over to the left of the 7, 3, enter, and it should tell you 0.4771. For a log of 0.2, you would type log, 0.2, enter, and it should tell you negative 0.6990. So finding log 5, if you punched in log 5, enter, it should tell you 0.6989. Log 0.5 is negative 0.3010. If you're noticing the pattern, anytime it's a decimal, it's going to be a negative. But you just punch it straight in your calculator to get the value. You can also use logs to solve exponential equations. If you have 3 to the x equal 11, well, we know that 3 squared is 9, and we know that 3 to the third is 27. We skipped right past 11. So there's some kind of decimal answer. To find it, you will rewrite it with log on both sides, okay? You're going to add log to the left and the right. Then you're going to move the exponent down to the front. So this x had to come down here and became x log 3 equal log 11. Then you're going to divide to get x by itself. The only trick is that when you put it in your calculator, when you put this into your calculator, you have to be sure and close parentheses. You're going to press log. It's going to automatically open. You're going to put 11, and you're going to have to close right here. You have to remember to do that. Then you'll say divided by, you'll press log, it's going to open for you, you put 3. This parentheses here when you close, it's whatever you want. It'll do it without it. And so then you would get approximately 2.1828. So for 4 to the x equal 15, you're going to put a log on both sides. So log of 4 to the x equals log of 15. You're going to move your exponent, so x times log of 4 is equal to log of 15. You're going to divide both sides by log of 4 so that you will have x by itself. So you take your calculator and you go log 15, close parentheses, divided by log 4, enter. And you get x is approximately 1.95. So 6 to the x equal 42, rewrite it with log. Log of 6 to the x is equal to log of 42. Move your exponent. X times log of 6 is equal to log of 42. Divide both sides by log of 6. So log 42, close parentheses, divided by log 6, and x is approximately 2.086. We also have what's called the change of base formula, and this is when they give you a value or an expression like this, log base 4 of 25. You can use the change of base formula to put it in your calculator. You take log of what we were finding the log of, divided by log of the base. So you would take your calculator and go log 25, close parentheses, divided by log 4. So another example would be if we had log base 2 of 5. What you would do is say log 5 divided by log 2 in your calculator. So log 5 close divided by log 2, and you would get 2.32. So log base 6 of 8 becomes log 8 divided by log 6 in your calculator. Log 8 closed divided by log 6, and x is approximately 1.16.
Looking at the back on number 5, you have log base 3 of 17. So this is going to become log of 17 divided by log of 3. You're just going to punch that in your calculator. Log 17, close parentheses, divided by log of 3, and you get approximately 2.58. Number 9, remember from your properties that division is subtraction, so this becomes log base 4 of 17 minus 5, which is 12, which becomes log of 12 over log of 4. So log 12 closed divided by log 4. You get 1.79. Remember, these are all approximate answers. Number 6 would become log of 13 divided by log of 6. Put it in your calculator. Log 13 closed divided by log 6, 1.43. Number 10, once again, you've got to subtract, and this becomes log of base 10 of 16 minus 2 is 14. So this becomes log of 14 over log 10. So log 14 closed divided by log 10, 1.15. Number 7 becomes log 7 over log 14. Log 7 closed divided by log 14, 0.74. Subtract here and it becomes log 240. So it's base 10. You ought to be able to just go log 240 and get 2.38. If you wanted to make sure that was right, you could go log 240 closed divided by log 10, and you get the same answer. Number 8 becomes log 16 divided by log 4. Log 16 closed divided by log 4, and you get approximately 2. I'm going to let you omit number 12. When you get to 13, you're solving. This is back where you've got to add x or add log to both sides. So log of 6 to the x is equal to log of 5. Move your x to the front, and it becomes x times log of 6 is equal to log of 5. So then you're going to divide. So log 5 closed divided by log 6, and you have approximately 898. Number 14 becomes, I'm going to go ahead and skip a step. It's okay if you can do this. X is going to come to the front. X log 5 is equal to log 23. I did the first 2 steps in one. So then you're going to say log 23 closed divided by log 5, and you get 1.95. Be careful on 15 and 16. It's going to be x minus 2 in parentheses. It's a unit times log of 3 is equal to log of 13. So log 13 closed divided by log 3 is 2.33. So x minus 2 is equal to 2.33. You've got to add the 2 so that you actually have your x by itself. So plus 2, and your answer is x is approximately 4.33. Same thing here, x plus 5 is in parentheses, times the log of 8 is equal to the log of 7. So log 7 closed divided by log 8 is 0.94. So x plus 5 is equal to 0.94. You're going to subtract your 5, so minus 5. And x is approximately negative 4.06. Okay, that's common logs. If you have any questions, call me over.